Welcome, this is Coach Dorf. We're going to now do an example of the following. We're going to try to find the limit as x goes to infinity of the square root of 2x squared minus 9 in the top of a fraction over 5x minus 6, which is in the denominator. All right, so let's write down the problem here. Now, to solve this, what I want to do is, if I were just to try to plug in, I can't plug in or substitute in x equaling infinity because infinity is not a number. If I put in a really large number for x, like let's say 5 gazillion, then this just gives me a really large number of a really large number, and that doesn't help me solve it either. So I can't do the substitution method here. So what I need to do is use some of the properties I do know. So one of the properties we know is that if I have a limit as x is going to infinity, and I have 1 over x to the p power, where p is greater than or equal to 1, then that limit equals 0. So an example of that is the limit as x over infinity of 1 over x equals 0. Or I have the limit as x goes to infinity of 1 over x squared equals 0. That's a fact that we talked about, that it's in the lecture notes. So that's a useful one that we're going to do here. All right, so to use that one, what I need to do is I need to get everything in the top and in the bottom so that it's either a number without a variable, or it has a number and then a variable in the denominator. The x is in the denominator. To do that, I look, for example, if I look at the denominator in this problem, we have 5x minus 6. So the degree on the top here, the degree, sorry, of the 5x minus 6 is 1 because I have x to the first power. I have 5x to the first minus 6. So it has degree 1. So I'm going to multiply everything on the bottom by 1 over x. Likewise, in the top, what's my degree? Well, I have a 2x squared minus 9 under a square root. The x squared is a second degree, so it's got a 2 there, but it's under a square root. And if I did the square root of an x squared, that's like just x. So it's also like a first degree. So I want to multiply it by 1 over x. Now the problem about the bottom I'm okay with, but the problem with the top is that I've got a square root. I can't just bring in that 1 over x under the square root. I want to write something that's equivalent to it with a square root. So 1 over x is the same thing as 1 over x squared under the square root. And that works because x is a positive number. All right. So I'm going to multiply the top and the bottom by those terms. And because the terms are the same, it doesn't change the answer. So on the bottom, I'm going to divide everything by x. And in the top, I have my square root. And I'm going to write my 2x squared minus 9 and divide everything by x squared. All right, so then that gives me, in the top, I have 2x squared over x squared minus 9 over x squared, and that's all under the square root. And then on the bottom, I have 5x over x minus 6 over x. And then I can do one more step and simplify that, and I get 2 minus 9 over x squared under the square root in the top, and 5 minus 6 over x in the denominator. Now we'll use this property that's in this box to the left here, and that tells me that the 9 over x squared, that's going to be 0, all right? Just like we have over here. And also the 6 over x is also going to be 0, just like we have on the left over there. So then I can rewrite what I have. If I take the limit now as x is going to infinity, that means I'm evaluating what the 9 over x squared as x goes to infinity, and I get 0. So by doing the limit here, I'm going to get the square root of 2 minus 0 in the top, and in the bottom I have 5 minus 0. And then that just simplifies to the square root of 2 over 5, which is our answer. Now, let's change this problem. Let's look at just a slightly different problem. Suppose I had the limit as x goes to negative infinity of the square root of 2x squared minus 9 over 5x minus 6. So the problem's the same, except now I'm going to negative, x is going to negative infinity instead of positive infinity. All right, and I notice the same thing. The degree in the bottom is degree 1. It's an x, it's the first power. The top, the degree acts like x to the first. Acts like a degree 1 polynomial. So I'm going to multiply top and bottom by 1 over x. And just like last time though, we want to bring that in the top, we want to bring that 1 over x into the square root. How do we do that? Well, last time we did this as 1 over x squared. Now, is 1 over x equal to the square root of 1 over x squared? Well, if x is a positive number, it is, but x is not a positive number in this case. It's x is going to a negative infinity. So x is a negative number. And if I look at it, what do I get in the 1 over x? If x is a negative number and I get 1 over x, that's a negative number. On the right-hand side, though, if I take the square root of 1 over x squared and x is a negative number, I get a positive number, right? Because I have 1 over a negative number squared. A negative number squared is positive, so I have 1 over a positive number. Let's take the square root of it, I get a positive number. So what I have here, this is not actually true. They're not equal to each other. But I can make them equal to each other if I put a negative sign here out front. So now 1 over x equals negative of the square root of 1 over x squared. Again, if x is a negative number, I need to put that negative sign in front of the square root so that they're equal to each other. With that, now I can continue with the problem. So then I have the limit as x goes to negative infinity. All right, and so now I'm going to bring in the x squared. I'll put the negative sign out front, and I've got the 2x squared minus 9 over x squared. And on the bottom, I have the 5x minus 6 all over x. Well, this is very similar to what we just did. The only difference is that I have a negative sign out front of the square root. So I can simplify this to the negative square root of 2 minus 9 over x squared all over 5 minus 6 over x. And just like last time, we know that this goes to 0 and this goes to 0. And so I have then the negative square root of 2 minus 0 over 5 minus 0, which now equals negative square root of 2 over 5. All right? See how those two problems are different. As x goes to infinity, I get one answer. As x goes to negative infinity, I get a different answer. Hope that helps.